One more section of statistics, 8.5, or section 5. We're looking at line of best fit. It says the table shows the hours studied and corresponding test grade earned by students on a recent test. Calculate the correlation coefficient R and determine whether R is statistically significant at the 0.1 level of significance. So the easiest way to work these, you could do it in Excel, which you will have to do for one of your labs, but I provide an example along with that lab for how to work these in Excel. So I'm going to work these in Desmos. It's a little bit easier, and I'll add that on here in a second. But what you do is you'll enter your table into Desmos, and then once you do that, you type Y1 and this little squiggle, B plus MX1. Or MX plus B. I'm doing it B first because of the next example. And it tells us that the R value, we don't need to know the line of best fit in this one. We just want the R value. And the R value is 0.752. We want to compare that to, or the absolute value of R, which would be positive 0.752, and we want to compare that to our correlation coefficient, or to our level of significance at 0.01. So here that is. So at 0.01, let's see, what is N? There's 12 of these. So N is 12. So 0.01 at 12 is 0.708. And notice how it says here is R is statistically significant if the absolute value of R is greater than the critical value. And yes, in this case, it is greater than. So yes, we are statistically significant. And then for example 2, this table gives data for the average temperature and snow accumulation in several small towns for a single month. Determine the equation of the regression line. And notice how it puts B naught plus B sub 1x. That's the same thing as MX plus B, but there's a little catch. When you put in your answer, you have to have the B naught first. So it has to be in this order here, or it's not going to count it right. Just a fair warning. Then determine if the regression equation is appropriate for making predictions at the 0.01 level of significance. So again, we're going to enter it into Desmos, and we'll put in Y1 squiggle B plus MX1, okay? And it comes out that our equation in that form with B coming first is 32.268 minus M was 0.568 and then times X. And it tells us that R is negative 0.7108. So we compare the absolute value of R, which would be positive 7108. And in this case, N is 10, I believe. We're just counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And we want the 0.01. So back over here, 10.01 is 0.765. And we want the absolute value of r to be greater than that, and it's not. It's less than. So that means that our equation is not appropriate. It is not statistically significant. The second example over here in Desmos. So what we do is we go to this little plus, and we're going to add a table. And we put in our values. So we have, under the x values, we have 40, 28, 17, 40, I think that's a 37, 20, 32, 17, 28, and 43. And then under the y values, 7, 13, 21, 10, 11, 25, 28, 20, 11, and 5. Okay, so hit enter and it'll take us down to a second area here, and that's where we're going to put y1, and you don't have to worry about putting the sub in somehow. If you just type y and then 1, it'll automatically take it down. And then we have the tilde button, which is in the top right corner of your screen, or if you can't find it, it is in here somewhere. There it is. And then b plus mx1. And there we go. So it tells us b and m, and that's what I've put over here. And it tells us r, which we compared to the coefficient or to the level of significance, and that told us it was not statistically significant. Okay.